our previous video we prepared benzil via the reaction from benzoin, which in turn was prepared from benzaldehyde, which we prepared before in a few different videos. Now we're going to continue this reaction sequence and use the benzil we prepared to synthesize benzilic acid. Benzilic acid is somewhat notorious because some of its esters were found to be extremely powerful military-grade incapacitating agents. 3-quinylvinyl benzilate, otherwise known as BZ, is the most well-known, and gives you an anticholinergic bad trip lasting 4 days. Some bad stuff. But don't worry, we're not going to go anywhere near anything like this. Here's our setup for the reaction. We've got the 100 ml flask set up on a hot plate with magnetic stirrer, and a smally big condenser set up on top. Let's get some water flowing. Okay, here's our solvent for the reaction. We've measured out 20 ml of methanol. We read a few different procedures and it looks like you can also use ethanol for this, and possibly also isopropanol as well. We chose methanol though because it has a lower boiling point and so there's less chance of us overheating the reaction mixture, which can lead to impurities. We've removed the condenser temporarily. Let's get the solvent in. Okay, here we go. Now for our starting material. 4.8 grams of benzil. We now add this to the flask. Here we are, all loaded and with the condenser reattached. At this temperature the solid isn't particularly soluble, so we now start to heat the mixture gently and get it up to almost refluxing. While it's heating we can prepare our other reactant. Here's 1.9 grams of solid potassium hydroxide. This is a 1.5 molar amount compared to the benzil. We're going to dissolve this in 5 ml of water. We love the sounds potassium hydroxide makes as it dissolves. Here we go, a nice clear solution. Put a pipette in this so it's ready for the reaction. Okay, back to our mixture. After a few minutes of heating the solid starts to dissolve. And now we've got a nice clear solution, so we're ready to do the reaction. Now we're going to add the potassium hydroxide solution drop-wise through the top of the condenser. As the first few drops go in the reaction mixture turns brown, then a very dark color. At the end of the addition the color is extremely dark, and also seems to have a slight purple tint to it. Now we just need to continue heating the mixture with the methanol gently refluxing for about 30 minutes. Okay, let's take a look at the reaction. The hydroxide acts as a nucleophile, and attacks one of the carbonyl groups in our starting benzil. But what then happens is a rearrangement. The phenyl group attached to that carbon hops over to the adjacent one, creating the carboxylic acid group. In order to do this you can imagine an intermediate species which contains the three-membered cyclic ring as the electron orbitals rearrange themselves. It doesn't seem likely when you look at it in theory, but it happens. The mixture is now starting to reflux gently, so we'll leave this now for 25 minutes more in order to react completely. Here we are on completion. You may not be able to see on the video, but the purple tint of the mixture is gone and the meniscus of the reaction mixture appears brown. So we remove the heat and allow to cool for a few minutes. And now we pour the reaction mixture whilst still warm into a beaker. Okay, we've covered this up and we're going to chill down now in order to see if we can crystallize out the potassium benzilate salt, which should be present. This takes a few hours, so be patient. During this time you can see crystals growing in the mixture. Here we are after a few hours. A mass of yellow crystals. So we set out to filter these. And got them nice and dry. Here's our potassium benzilate. It looks a bit like brown sugar. However, there's only about 2 grams here, which isn't a lot, and we were expecting a bit more than this from the reaction. So we decided to process the filtrate that we collected to see if we could get more product. Okay, here it is. We evaporated this down on a hot plate to remove the methanol. As we did so, strange patterns and apparitions formed in the dish, as if a portal to a parallel universe had opened up before us. Pretty soon this evaporated off, and on cooling the contents crystallized. So we've got some more crystals here. We filtered these and washed them with about 10 ml of ice-cold methanol. Here's our second batch. Another 1.7 grams of crystals. This time the methanol wash has removed the color, but we do notice that the crystals are slightly different to the first batch and more flaky in appearance. So we don't know how pure they are. Okay, here's our potassium benzilate. Now we're going to dissolve this in hot water and then convert into the carboxylic acid. We're starting off with 50 ml of water, and we've got this in the beaker on a hot plate. Let's add our potassium benzilate. First batch. And the second batch. Now we're going to heat and see if we can get this to dissolve. We covered the top of the beaker with plastic wrap in order to insulate a little bit. Well, it's pretty hot and there's a lot of solid undissolved, so we're going to add some more water. Getting hot again. And still we've got some solid undissolved, so we add a bit more water to make up to about 100 ml in volume. It looks like there's some fluffy brown material which just won't dissolve. So we decided to use a spatula to remove this from the surface. Okay, most of it has gone now, so we're ready to do the conversion. Here's 10 ml of concentrated hydrochloric acid, which should be more than enough to convert all our product into the carboxylic acid. We add this to the hot mixture. Let's check the pH. Strongly acidic. We removed any remaining brown fluff from the surface so the mixture was nice and clean. We're not too sure what this is. Perhaps it's simply excess potassium benzilate and we were overcautious with the recrystallization, or perhaps it's a byproduct. We'll have to do some more research to find out exactly. Here's our hot solution. We're going to let this cool down slowly, and then chill it down in order to crystallize the benzilic acid in the solution. As it cools, sparkling white crystals appear in the mixture. We left this chilled out for a while and then set up for filtration one last time. And here we go. Our final product. Benzilic acid as silvery flaky crystals. It looks a little bit like phenylacetic acid, only it has a very slightly faintly sweet sugar aroma. The final dry weight was 1.3 grams and this corresponds to a 25% yield on our starting benzil. This isn't a great yield, so perhaps we added too much potassium hydroxide, or perhaps we boiled the mixture for too long. But it seems very pure and we're pretty happy to have isolated a nice pure product. We're not sure where we can go with this now, but we'll have a think and let you know if we find an interesting use for it. But please don't ask us to make busy. Thanks for watching, and stay tuned for more reactions.